Right now, as you watch this video, something impossible is happening in our atmosphere. Carbon dioxide, the gas we're told is heating up our planet, is actually freezing part of Earth's sky, and scientists just figured out how. This discovery, published just days ago, reveals one of climate change's strangest secrets, and it's rewriting what we thought we knew. Let's start with what you already know. For decades, we've been told the same story. Humans burn fossil fuels, releasing carbon dioxide into the air. That CO2 traps heat like a blanket around Earth, warming our planet, melting ice caps, rising seas, extreme weather. The greenhouse effect, simple, right? And that's all true. Earth's surface temperature has risen about 1.2 degrees Celsius since pre-industrial times. The evidence is everywhere. But here's what no one talks about. While the bottom of our atmosphere is heating up, the top of our atmosphere is doing the exact opposite. It's getting colder, much colder. And the same molecule causing both? Carbon dioxide. This is the CO2 paradox, and until this week, scientists couldn't fully explain it. Think about that for a second. The same gas that's making your summer days unbearable is simultaneously turning the stratosphere, that's the layer of atmosphere about 10 to 50 kilometers above your head, into an icebox. Over the past few decades, while ground temperatures climbed, the stratosphere has cooled by nearly 2 degrees Celsius. That might not sound like much, but in atmospheric science, that's massive. It's happening faster than the surface is warming. So what's going on? How can one molecule be a heater and an air conditioner? Here's where it gets beautiful. Researchers at Columbia University just cracked the code, and the answer is all about where the CO2 is and what it's doing there. Near the surface, in the troposphere where we live, CO2 acts like a blanket. When infrared radiation from Earth tries to escape to space, CO2 molecules absorb it and trap that heat. More CO2, more trapped heat. Classic greenhouse effect. But up in the stratosphere, the game changes completely. Up there, the air is incredibly thin. There's barely anything, just a few molecules floating around in near vacuum conditions. When CO2 exists in this thin environment, it doesn't trap heat, it releases it. The CO2 molecules absorb energy from the sun. But instead of passing it to other molecules like they do down here, because there are no other molecules nearby, they radiate that energy directly back into space as infrared light. The more CO2 you pump up there, the more efficiently the stratosphere can dump heat into the void of space. And here's the kicker. The stratosphere was already cold to begin with, around minus 60 degrees Celsius. But now, with more CO2 up there, it's getting even colder, even faster. The scientists discovered that carbon dioxide isn't just cooling the upper atmosphere, it's one of climate change's most visible fingerprints. Now you might be thinking, okay, cool science fact, but why should I care if some layer of atmosphere I'll never visit is getting colder? Great question. This matters for 3 huge reasons. First, climate models. Understanding this cooling effect helps scientists make better predictions. It's a critical piece of the climate puzzle that confirms our models are accurate. When we see both effects, surface warming and stratosphere cooling, exactly as predicted, it proves we understand what's happening. Second, the ozone layer lives in the stratosphere. When the stratosphere cools, it actually helps the ozone layer recover, because the chemical reactions that destroy ozone slow down in colder temperatures. So ironically, the same CO2 warming our planet is helping heal the hole in our ozone layer. But here's the third reason, and it's the most mind-bending. As the stratosphere cools, it contracts. It literally shrinks. The edge of space is getting closer to Earth. Satellites are experiencing less drag. The entire structure of our atmosphere is shifting. We're not just changing the temperature of our planet, we're changing its shape. So there you have it, the CO2 paradox. The atmosphere is changing above you right now, both hotter and colder, both expanding and contracting, both trapping heat and releasing it. Welcome to the beautiful, terrifying complexity of climate science.